All right, number 6, we knew what was coming, a Maclaurin series. Here we go. The Maclaurin series for a function f is given by this series, and then it gives you the terms of the series, and converges to f of x for the absolute value of x being less than r, where r is the radius of convergence of the Maclaurin series. Use the ratio test to find r. So we're going to find the limit as n approaches infinity of a sub n plus 1. So we're going to get, and we're taking the general term when we do the ratio test, we'll get negative 3 to the n plus 1 minus 1 times x to the n plus 1 all over n plus 1 divided by just the series, negative 3n minus 1 times x to the n over n. And I would suggest writing it as a fraction first before you change it to the multiplication of the reciprocal. I think the scorers would like it if you did that. So we're now going to have negative 3 n plus 1 minus 1 is just going to be n times x to the n plus 1 over n plus 1. Now I'll multiply by the reciprocal. We'll get over n over negative 3 to the n minus 1 times x to the n. Okay, so now just seeing if we can do anything with this. If I have negative 3 to the n and negative 3 to the n minus 1, I can subtract the exponents. When I do n minus 1, I'm actually just going to get negative 3 to the first. So it's going to be negative 3 to the first times nothing I can do with that n. And then on this one, x to the n plus 1 over x to the n, if we subtract the exponents, we'll get times x. And it's all going to be over n plus 1. Right? And then we're going to find the limit as n approaches infinity. So if I plug in infinity for both of those, I will end up getting infinity over infinity, at which point I'm going to use L'Hopital's rule. So I will get the negative 3 and the n are just going to, the negative 3 and the x are just going to tag along here. So negative 3x would be the derivative of the numerator, and 1 would be the derivative of the denominator. So I was finding the limit as n approaches infinity, and that will just equal negative 3x. All right, when we do this, we know that the absolute value of negative 3x has to be less than 1 in order for the ratio test to hold. So we know that if I take the absolute value of that, I just know that we're going to have 3x being between 1 and negative 1. And then if we'll just divide all 3 parts by 3, I'll get negative 1/3 is less than x is less than 1/3. I do not need to test the endpoints because it just asked me for the radius of convergence. So to get the radius of convergence, we're just going to take 1/3 minus negative 1/3, which gives me 2/3, and then we just take half of that. So the radius of convergence would be 1/3. Okay, so my radius r is equal to 1/3. That would be 3 points. I would get 1 point for setting up my ratio, so setting up the ratio, so it has to be a ratio, so do not just write it like this to start with. You want to write it as a ratio. When you found the limit of the ratio, which was negative 3x, that is worth a 2nd point, and then if you actually found that radius of convergence, that was worth your 3rd point for that part. Okay, part B. Write the first 4 non-zero terms of the Maclaurin series for f prime, the derivative of f. Express f prime as a rational function for the absolute value of x being less than r. Okay, so from here, this is f right here. Okay, it said to find the first 4 non-zero terms for f prime. So all we need to do to get f prime is just take the derivative of each of the terms. And we do want 4 terms when we do this. So the derivative of x would be 1 minus the derivative of 3 halves x squared would be 3x plus the derivative of 3x cubed would be 9x squared, and now I'm missing a 4th term, so I'm going to have to find one more term in the sequence. So we're going to, this was n equal 1, n equal 2, n equal 3. We need to find what's happening when n equals 4. So when n equals 4, we can just go ahead and plug it into this formula right here. They're actually both the same, so it doesn't really matter. So when n equals 4, we're going to get negative 3 to the 4 minus 1 over 4 times x to the 4. So this will be 3. Negative 3 to the 3rd power is negative 27 over 4x to the 4th. So since that's the 4th term, if I take the derivative of that 4th term, I'm going to get negative 27x cubed. So I found those first 4 terms right there. That was worth 2 points. Okay, and then the next one, it says to express f prime as a rational function. So this comes back to that doggone formula recognition, and hopefully maybe you'll recognize that this is The Maclaurin series for 1 minus x looks like this: 1 plus x squared plus x cubed. And if we, to get this formula, we would do 1 plus, we would plug negative 3x in for all of our x's. And if I did that, I would get what we started with. So since this is the Maclaurin series for it, we replaced the x with the negative x. This would be 1 over 1 minus negative 3x. So the rational function that would go with this would be 1 over 1 plus 3x. That was worth a point, so don't worry too much about it if that part did not work out so well for you. So that was worth 3. Okay, part C. Write the first 4 non-zero terms of the Maclaurin series for e to the x. Use the Maclaurin series for e to the x to write the third degree polynomial for g of x equals e to the x times f of x about x equals 0. So this is another case, I know we had it in our multiple choice problems, where we needed to know what e to the x is. So this would definitely be worth memorizing. The first 4 terms of e to the x are 1 plus x squared over 2 factorial plus x cubed over 3 factorial. So it said to write the first 4 non-zero terms of the Maclaurin series. That was worth 1 point. So just memorizing a formula was worth a point, which is awesome. All right, now it says to use that to write a third degree Taylor polynomial, third degree, so the highest power is going to be 3, for e to the x times f of x. So g of x is going to be e to the x, which was 1 plus x squared, and I'm just going to change that over 2, plus x cubed over 6, times f of x, and we know f of x is this, so x minus 3 halves x squared plus 3x cubed. And I could actually, if we wanted to use our answer from part A, we could actually go one more term if we wanted to. Okay, so now we just want to find that answer, and it's going to be a third degree Taylor polynomial, so we're just going to do lots of foiling. So I'm first of all going to distribute the 1 to every part. So when I distribute the 1 to every part, I'm going to get x minus 3 halves x squared plus 3x cubed minus 27x to the 4. Okay, now I'm going to distribute the x to all the parts. So I'm going to get x squared minus 3 halves x cubed plus 3x to the 4 minus 27x to the 5th. Okay, and then I'm going to distribute the x squared over 2 to all of the parts. Okay, I'm going to get plus x cubed over 2 plus, and I'm going to stop right there because this has to be a third degree polynomial, and as soon as I start, and I'm going to have to cross those out because they're higher than degree 3. As soon as I start taking this x squared times the other ones, they're going to be bigger than x cubed. So I don't even have to worry about actually all those. And then if I take x cubed over 6 times everything, they're all going to be bigger than an x to the 3rd power. So I don't even have to bother doing that. So now from here, I'm just going to combine some like terms. I should get x. There was nothing to go with that one. Let's see here. Negative 3 halves x squared plus, and actually I'm going to cross that one off too because it was too big. Bigger than degree 3. Negative 3 halves x squared plus x squared will give me negative 1 half x squared. And then 3x cubed minus 3 halves x cubed plus 1 half x cubed. Let's see, what will they give that? Give us negative 1. I think that will give us plus 2x cubed. Okay, so that is my third degree Taylor polynomial, the highest degree, and that is 3. So that was worth 2 points. And it doesn't really give me a breakdown other than that's what we got. So it was worth 2 points. So that is worth 3 points altogether. And there we go.